Hello everyone, welcome back to my YouTube channel CSN IT Tutorials by Vrishali. In our previous sessions, we have discussed about what exactly CPU scheduling algorithm, then FCFS algorithm with solve examples. I have attached a complete OS playlist link in below description box. Now, in today's session, we will discuss the next important topic, that is shortest job first. Here I will give you a easiest tricks to solve this example. Let's start the session. Previously we have already discussed all these subjects in detail with examples. I have attached playlist of all these links in below description box. Please subscribe my channel and also share this with your friends. Now, these all topics we will cover in today's session, and at the end we will discuss some important question bank. As we discussed earlier, operating system follows the multitasking environment. Multiple tasks and processes are work parallelly. Now, there is a scheduler in operating system. Scheduler manage and decide order of each and every process for the execution. And this process is called as scheduling. So, there are different types of scheduling algorithm in operating system. In our previous session, we have already discussed how to solve FCFS scheduling algorithm example step by step. I have attached link of this video in below description box. Now, in today's session, we will discuss SJF scheduling algorithm. Let's see. Now, the name suggests that shortest job first. It means in operating system, there are multiple processes. Now, those process having the shortest burst time means execution time. So, those process having the shortest burst time, that processes have executed CPU by the first. This is a concept of SJF CPU scheduling algorithm. And if two or more processes having the same burst time, at that time they follow the first come first serve scheduling approach. Now, in our previous session, we have discussed about preemptive versus non-preemptive scheduling algorithm. So, SJF is the non-preemptive scheduling algorithm. Non-preemptive means when operating system allows CPU to the process 1 for execution, but at the same time process 2 have came. But still, CPU first executed process 1 and after completion only they executed process 2. Basically, they follow the first come first serve manner. There is no any interruption. So this is called as non-preemptive algorithm. Again, this SJF algorithm generally used in oldest version of operating system like batch operating system, embedded systems and different compiler job scheduling. One of the main advantages, this process give minimum average waiting time as compared to FCFS. Now let's discuss how to solve the example. So, before solving example, you must know about some basic terminologies in CPU scheduling algorithm. We have already discussed all these terminologies in detail in previous session. Here, I am giving you a quick revision of it. See, the first one is the arrival time. In new state, your process have created. Then this process move forward to the ready state for execution. So this is called as arrival time of particular process. Burst time means actual time is required for the execution. Next one is a completion time. After execution, your process goes to terminated state. So this is called as completion time of your process. Next, turnaround time. It means total time from arrival to completion. And the formula is completion time minus arrival time. Next one is a waiting time. Due to some interrupt or due to some allocation reason, your process goes to the waiting state. So this is called as waiting time. The formula is turnaround time minus burst time. Next one is the response time. When CPU is allocated to the particular process first time, this is called as response time. And at the end, there is a Gantt chart. Gantt chart is a visualization chart. Basically, this chart display each and every details about the process. Means process arrival time, process completion time. They show every details in visualized manner. That's why Gantt chart is one of the most important thing while solving example in CPU scheduling. So let's see how to solve the example. This is your first example. This example is important for your university exam and GATE exam purpose. In GATE exam, they generally ask like to find out the turnaround time of P3 process, then to find out the waiting time of P2 process in this way. So prepare accordingly. Now, the first step is you need to analyze which data is given and which data you need to find out. See here in this particular table. So there are total 4 processes. Process 1, process 2, then P3 and P4. Clear? Now arrival time is given. P1 is arrived at 1, P3 is arrived at 2, P3 is arrived at 1 and P4 is arrived at 4. So let's assume that 1 means 1 o'clock, 4 means 4 o'clock in this way. It is easy to understand. Now the next one is a burst time. Burst time means actual time required for the execution. So P1 required 3 unit of time for execution, P2 required 4 unit of time, P3 required 2 unit of time and P4 required 4 unit of time for execution. So let's assume that 2 means 2 o'clock, 4 means 4 o'clock in this way. So this data is given. Now you need to find out completion time, turnaround time, waiting time, then average turnaround time and average waiting time. So this type of question generally asked for 8 to 10 marks in your university exam. So let's see how to solve this. The first step is you need to draw the Gantt chart. Gantt chart shows the visualization way of each and every process. It is easy to solve the particular example. Now it always start with the 0. Now check that which process having arrival time is 0. There is no other process has came at 0 timing, right? So for 1 unit of purpose, your CPU goes to the idle state. CPU goes to the idle state means your CPU is free. There is no other process is between 0 to 1. Clear? Now at 1 o'clock, which processes has came? See here. P1 arrival time is 1. P3 arrival time is 1. Means at 1 o'clock there are total 2 processes. So just draw one queue here. This is your queue. So at 1 o'clock 2 processes are there, P1 and P3, right? So queue just like a waiting state. Means all the processes are waiting here for the execution. Clear? Now 1 o'clock there are total 2 processes. As per the SJF scheduling algorithm, you need to find out which process having the shortest burst time, shortest execution time. See here, P1 has burst time 3 and P3 has burst time 2. So which one is the shortest? 2. So CPU executed P3 first. This is a concept of SJF scheduling algorithm. They executed particular process as per the shortest burst time. See, at 1 o'clock P3 has came, right, because they having the shortest burst time. So what is their burst time? 2. So 2 plus 1, that is 3. Means from queue your P3 process have executed, right? Now next, at 3 o'clock or between 1 to 3, which process has came? See, between 1 to 3 P2 is there, right? Means when CPU is busy with P3, P2 process has come, but CPU is busy, so this P2 process goes to the waiting state here, right? Now in queue there are total 2 processes, P1 and P2, right? Now to find out the burst time, which one has the shortest burst time? P1 their burst time is 3 and P2 process their burst time is 4. Which one is the shortest? P1. So CPU executed P1 first. See here, right? What is their burst time? 3. So 3 plus 3 is equal to 6. Clear? So from queue, second time your process 1 have executed. Clear? Now again check. At 6 o'clock or in between 3 to 6, which process has come? See, there is a P4 process because P4 arrival time is 4. Suppose CPU is busy with P1 here, right? So at 4 o'clock, this P4 process has come, but CPU is busy with P1, so your P4 process goes to the queue in waiting state, right? Now in your queue there are total two processes, P2 and P4. Now check the burst time. So P2 process has burst time 4 and P4 process again has 4 burst time. Means both processes having the same burst time. So at that time you can use first come first serve approach. Just check their arrival time. So P2 arrival time is 2 and P4 arrival time is 4. Which one come first? P2, right? So CPU executed P2 here. Clear? What is their burst time? 4. So 4 plus 6 equal to 10. Right? Means your P2 process have executed from the queue. Now in queue there is only one process is there like P4. So just execute here P4 process. What is their burst time? 4. So 10 plus 4 is equal to 14. So in this way CPU executed one by one each and every process as per their burst time. So your P4 process has executed. Clear? Now as per the Gantt chart you need to find out the value of this. See, the first one is a completion time. Check. P1 completion time is 6 here. Clear? This is the arrival time and this is the completion time. P2 completion time is 10. Next P3 completion time is 3 and P4 completion time is 14. So total completion time of execution of all this process, that is 14. Clear? Now next one is a turnaround time. See, burst time means actual time required for the execution. But sometimes what happen? Your CPU is busy with other process. So your process goes to the waiting state. So that was indicated by the turnaround time. So exactly how much time is required for the execution? Waiting time plus your execution time in this way. Clear? See, the formula of turnaround time is completion time minus arrival time. So in P1 process, completion time is 6, arrival time is 1. So their turnaround time is 6 minus 1, 5. Next, P2 process 10 minus 2 is equal to 8. Next, P3 process 3 minus 1 is equal to 2. And P4 process 14 minus 4 equal to 10. Means P1 process required actual time 3 hours for the execution, but due to some waiting time, they actual required 5 hours for the execution. Clear? This is the meaning of this thing. Now the next one is a waiting time. The formula of waiting time is turnaround time minus burst time. Now see here, P1 process waiting time is turnaround time is 5 minus burst time 3. So that is 2 hours. Means for 2 hours, 2 unit of time, P1 process goes to the waiting state. Clear? Next, P2 process waiting time is 8 minus 4, that is 4. Next one is a P3 process waiting time is 2 minus 2 equal to 0. And P4 process waiting time is 10 minus 4 equal to 6. So 2 hours, 4 hours, this process goes to the waiting state. So by using Gantt chart, it is easy to find out all this value. Now again to find out the average turnaround time. And the formula is total turnaround time divided by process. So total of all this thing is 25 divided by there are total 4 process, right? And average turnaround time is 6.25. Again find out the average waiting time. The formula is total waiting time divided by total process. So just take the addition of all these things. So total waiting time is 12 divided by total process 4 is there. So average waiting time is 3. So in this way you need to solve this example. Now let's understand the second one. So this is your second example. I am taking different types of example, so you should clear your better basic understanding regarding shortage job first scheduling algorithm, right? See here. Now again check which data is given. There are total 4 process P1, P2, P3 and P4. Arrival time is given. P1 is arrive at 0, P2 is arrive at 4, P3 is arrived at 4 and P4 is arrived at 8. Burst time is given. P1 required 6 unit of time for execution. P2 required 10. P3 required 4 unit of time and P4 required 3 unit of time. So this data is given. And you need to find out similarly completion time, turnaround time, waiting time, then average turnaround time and average waiting time. So the first step is just draw the Gantt chart. It always start with the 0. Now check. At 0 o'clock, which process has come? Means which process arrival time is 0. See here, P1 process arrival time is 0. Means first CPU will execute the P1 process. So just draw one queue here. So in particular queue at 0 o'clock P1 process has come. There is only one process is there, right? So CPU execute this process. And what is the burst time of P1? 6. So 6 plus 0 equal to 6 here. So between 0 to 6 CPU is busy with P1. Clear? So CPU executed P1 process. Now next step. Check. At a 6 o'clock or between 0 to 6 which process has come. See, between 0 to 6 P2 process arrival timing is 4 and P3 process arrival timing is 4. Means when CPU is busy with P1, there are total 2 process has come at 4 o'clock, right? But CPU is busy with P1, so this 2 process has goes to waiting state in particular queue, right? Now there are total 2 process having this same arrival time, right? P2 and P3. So check that which process having the shortest burst time, which process required the shortest execution time. So P2 required 10 unit of time for execution and P3 required 4 unit of time. Which one is the shortest? P3, right? So CPU executed P3 first. So what is their burst time? 4. So 4 plus 6 equal to 10. Clear? Means from Q at second time your P3 process have executed. Now next check. At 10 o'clock, which process has came? At 10 o'clock or between 6 to 10, there is a P4 process, right? When CPU is busy with P3, P4 process has come at 8 o'clock, right? But CPU is busy, so this P4 process goes to the waiting state, right? Now there are total 2 process in queue, P2 and P4. Check which one has the shortest burst time. P2 their burst time is 10 and P4 their burst time is 3. Which one is the shortest? P4. So CPU executed P4 process first. Their burst time is 3. So 3 plus 10 equal to 13. Means your P4 process have executed. Now there is only one process is remaining, that is P2 process. So at the end CPU executed P2 process. What is their burst time? 10. So 10 plus 13 equal to 23. Means your P2 process have executed. Clear? In this way CPU executed each and every process as per the SJF scheduling algorithm. Now to find out all this value. Check. What is the completion time of P1? 6 here, right? What is the completion time of P2? 23. What is the completion time of P3? 10. And what is the completion time of P4? 13. Clear? Next to find out the turnaround time, and the formula is completion time minus arrival time. So completion time is 6, arrival time is 0. Means turnaround time is 6. Next one is P2 process turnaround time 23 minus 4, that is 19. Next P3 process turnaround time completion time 10, arrival time 4. So 10 minus 4 equal to 6. Then P4 process 13 minus 8 equal to 5. So these are the turnaround time. Again find out the waiting time. So formula is turnaround time minus burst time. So turnaround time is 6 and burst time is 6. 6 minus 6, 0. Clear? So they required the 0 unit of waiting time. Next one is P2 process 19 minus 10, that is 9 unit. Next P3 6 minus 4, that is 2. And last P4 process 5 minus 3, that is 2. So these are the waiting time. Now find out the average turnaround time, and the formula is total turnaround time minus divided by total process. So just take a addition of all these things. The addition is 36 divided by total process 4, means their average turnaround time is 9. Again find out the average waiting time, total waiting time divided by total process. So just calculate the addition of this, that is 13 divided by 4. So the average waiting time is 3.25. So in this way you can solve different types of example. Now as per your previous year question paper, these are the some important question like what is SJF scheduling? Explain with example. And mostly example is given like process arrival time and burst time. You need to find out their Gantt chart, average waiting time and average turnaround time. Again you need to check whether it is preemptive or non-preemptive scheduling algorithm. Clear? So prepare this topic completely. So thank you and stay tuned for my next topic.